Hello, this is part 3 on parabolas. This is chapter 9.3 in the text that RVCC is using in the fall of 2020. This deals with applications for parabolas, but also identifying parabolas from other conic sections if you're given a standard format. Okay, so identifying conic sections. If we have just this general format, if we have a whole bunch of stuff, we have x squared, we have y squared, we have x's, y's, and a constant on one side of the equation equals 0, we want to decide whether it's a circle, a parabola, an ellipse, or a hyperbola, like what type of conic section it is. If a is equal to c, then we're going to have a circle. If AC is equal to 0, that means that we only have one x. We either have x squared or we have y squared, but we don't have both. One of those terms is not there because one of them is equal to 0. So when we multiply a times c, we're going to get 0. That means it's a parabola, because in parabolas we only have one squared variable. If a times c is greater than 0 and a isn't equal to c, it's going to be an ellipse. So if these have the same sign, we have an ellipse. If they have the opposite sign, AC is going to be less than 0, and we're going to have a hyperbola. Okay, so let's take a look at a couple examples. We have this one here. We have 3x squared plus 2y squared plus 12 plus 4y plus 2. We don't really care about the rest of this stuff. We just care about this 2 and this 3. They have the same sign. So AC is greater than 0, and A does not equal C. So this is going to be an ellipse. Okay. Our next example, we have x squared plus y squared. So we don't have it right here, but this coefficient is a 1 and a 1. So they're the same. So A is equal to C. So this is a circle. Our next example, we have y squared minus 12x. Well, we don't have an x squared, so we just have this y squared. So C is equal to, or A is equal to 0. So this is equal to 0. So this is going to be a parabola. In our next example, we have 9x squared minus 16y. And I don't care about the whole rest of it, honestly. If I'm just identifying what type of conic section is this, we have a 9 and we have a negative 16. So that's less than 0. The signs are opposite. And it doesn't matter which one's positive and which one's negative. They just have to have one positive and one negative. And this, then we know that this is a hyperbola. And I wanted to look at some applications of parabolas. So just some basic background. If a parabola is rotated about its axis of symmetry, we have a parabolic surface. So that's symmetrical, right? Because we're rotating around. And that parabolic surface will reflect light. Light that originates at the focus will hit the parabolic surface and bounce back so that the outgoing light is parallel to the axis of symmetry. So they use this like for spotlights and searchlights and flashlights. If you want to amplify that light, you put that light source at the focus, and then the light will shine directly out and not go in all different directions and be dispersed. Okay, so if you create a flashlight from a parabolic surface that is 6 inches in diameter and 4 inches deep, where should you place the light source? Okay, I always draw a picture. Some people can do this without, but I'm going to draw a picture. We have a parabola, a parabolic surface like this. I don't like that. A parabolic surface. It's 4 inches deep, and it's 6 inches across. This is 6. So we can know this point. This point here is half of 6. It's going to be 3, 4. And this point over here is going to be negative 3. 4. So that's the trick with all of these. And I know I didn't do the applications for the hyperbolas or ellipses, but that's the key, is to identify the points and plug them into the equation and find out what you need, or find out what your the other variables in that equation are. For parabolas, we have to find out what p is. So we know this is a parabola that opens upwards. We know that we have a format of x squared is equal to 4py. Okay, so this is just like the standard equation of a parabola that's centered at, or with a vertex at the origin. So in all of these, we want to put the vertex at the origin so that it just simplifies everything. So now we have this point 3, 4. We can plug in 3 for x and 4 for y. So we have 3 squared is equal to 4py. Okay. So, oh, sorry, not y, right? We were going to plug in 4 for y. So 4p, 4. So 3 squared is 9. 4 times 4 is 16p. Divide both sides by 16. We get p is equal to 9/16. Okay. So we want to put our light source here at 9/16. So this is going to be 0, 9/16. Okay. Because our focus, remember, we're moving p from our vertex to our focus. So we're going to move up 9/16 from our vertex, which was 0, 0. So the light source should be placed at 0, directly above our vertex, and 9/16. Okay, so the trick in all of these is putting your vertex at 0, 0, and then finding 2 points, finding out if you need an x squared equation or a y squared equation, finding out what p is, and then solving from there. Okay? If you have questions on how to graph parabolas, there's 2 other videos on those, and please take a look.